what is a function, why do we need functions, types of functions, and why functions rule, which is why do we need to learn functions, and how do we use functions, when do we use functions. Under common misconceptions, two important topics of scope of a variable and passing arguments and parameters into function have been included. At the end of this lecture, let us also explore various programs that we can do. So now let us understand what a function is. A function is a self-contained block of code which performs a specific task, which means a function is like a mini program which is defined to perform a specific thing. Specific, probably it can give a specific output, or it can also just execute certain instructions. We'll look at how it does all these things later, but yeah, right now function is a self-contained block of code. It is like a chunk of code which has its own independent objective. It performs a certain set of instructions. Let us now understand why do we need a function. So you can see a toolbox over here. We have various tools: hammer, spanner, everything. They have their own independent motives. Like a hammer is used to hammer a nail, and spanner is used to unscrew bolts and stuff. So similarly, we need functions to do different kind of things, or different kind of work in a program. So we can divide it and then perform it. For example, let us consider adding function. Like we are familiar with adding function, which is a plus b. So in mathematics also we use functions like y equals to f of x, right? So let us see what that means actually, which means y equals to f of x means we have y, which is the output, and x, which is the input. We give an input into the function and we get an output. So in functions which we will be writing, sometimes we may not get any particular output and we may not give any input. It will just perform a specific set of instructions. But yeah, usually we send something into it and we get an output. So this is how functions are in mathematics as well. So we use this because we need a specific output, or we need a specific set of instructions to be executed. And we have complex problems, like there's a long problem which is being done. So in that we break it into chunks and then execute it. So that is why we need functions. So it simplifies complex work into smaller chunks. So that is function. We can also reduce duplication of code, which is, for example, if we want to add two things, instead of writing the code again and again, we can just declare a function which will add two numbers and use the same function again and again. So this is reusability of the code. It promotes reusability, and it also enhances code readability, which means it will be easy for us to read the code and also debug the code whenever required. Now let's look at the types of functions. There are built-in functions, which is we can use print length. Print is for printing a certain a string or something on the screen. We can print whatever we want on the screen, which you have learned. And length is to find out the length of string or lists. So these are built-in function. They are already present in Python's standard library. They are predefined. We just have to call them and use them. And there are user defined functions where we have to write the code and define what set of instructions they have to perform. We now also you need to understand why you need to know functions, because functions are the point where it turns your complexity of problems, which means before, if you would be after learning loops, the complexity of problems you would be solving would be somewhere around here or something. Functions are the point where after learning functions, the complexity of the problems you solve will rise rapidly. So that is why you need functions. Apart from that, it also increases efficiency, solving skills, and as I said, it enhances modularity of your code, which is it breaks down your code into chunks, independent chunks, which independent set of instructions which are executed, and also it reduces repetition of code. How do we use function? Let us understand the usage of it and the syntax. So let me open Jupyter Notebook. So we use the def keyword. Uh, we use the def keyword, so you can see that it gets highlighted. This means that we are defining a function. So probably I can say a function, and this is how I defined a function. We have the def keyword, function, and then parentheses. In this parentheses we can pass values if we want, but yeah, this is how we define the function. We can also use doc strings, which is three double quotes, which would be used. So these are optional. These are like comments where you can describe what this function will do. For example, let me say it will print function. So let me say print, and it will print function. So I have to call this function now. This will be done by this method where I call the function with parentheses, and then it prints the function. It is actually connecting to kernel. Let me do it in another notebook. Now let me call function. So it prints function for me. So this is how it works. Uh, Also, let us look at functions which can return values. Suppose I define an add function where I am passing a and b. So let me pass a and b, like I said, y equals to f of x. It's a function, right? You pass x into it, which is you give x as the input and y is the output. So here we're giving a and b as the input, and a plus b will be something which should be the output. So for the output I'll use the return keyword. So this will be the output. After this, any piece of code you write in this will not be executed. And also in Python, when you write this, it automatically gets indented to the extreme left, because this is how it works. So in Python, following the indentation becomes very important, because this is how functions will be executed. So if this is add function, whatever you want to do in this function must appear in the same block, and that is how they are indented. So this is a plus b, and let me call this function, and I'll pass 2 and 2 into it. 2 plus 2 is 4, so it returned 4 to me. So this is the output, which is whenever we have an output, the cell shows out, and whenever it is just printing, it does not show anything. So this is how we write functions. So we use functions whenever we want to break down a complex problem into smaller manageable steps. When we want to use the same function many times. Uh, and when we want to reuse the same code logic many times, we use functions. So as I said earlier, let us understand this here. A function has two parts, header and suit. Header is the keyword def and function name. Suit is it is followed by the round parentheses and the colon, and then suit is the statements of Python, which is this one. So if you want to know the syntax, it would be def the name of function. It is also advised to use snake casing in functions because camel casing is used in classes. So if we are writing function name, this is camel casing where the next word is the first letter of next word is in capital. This is used for classes. So we use snake case where the underscore separates two words. So this is the syntax of function, and this is suite. Suite is the the rest of the code which we write. So let's now look at common misconceptions. Common misconceptions are confusing parameters with arguments. So parameters are placeholders defined within the function, while arguments are actual values. And we'll also look at the scope issues. Um, Let us look at parameters and arguments. Parameters are used to give inputs to the function. They're specified within parentheses in function definition. Whereas arguments are something which is used in calling the function. So, for example, let us say the same add function. Let us consider the same add function. If I say DEF. So here we have A and B, right? So these A and B are parameters because they are specified in the pair of parentheses, and the arguments are 2 and 2 because when we are calling the function we are passing 2 and 2 into it. So that is why this is argument and this is parameter. Uh, Let me write another function just to ensure this is completely done. Let me say x, y, and z. So this is the function. These are the parameters. X, y, and z are parameters. So a is equal to x plus y, and b is equals to a multiplied by z. We have to return b. So b is the output. So if I print and I call the function inside the print statement, and I pass 10, 5, 2 into this, I'll get 30. I'm sorry. So this is how parameters and arguments work. So parameters and arguments are different in this way. So here x, y, and z. So here is 10, 5, and 2. So arguments are assigned to corresponding parameters inside the function. Now let us look at different categories of functions. So before that, let us look at scope of variable. So there's local scope and global scope. So variable defined within functions are accessible only inside that function. So when I say a here, a is inside my function, so a is accessible only inside my function. In global, if I say print a, it gives me an error because a is not defined and a is defined only in my function. So but if I say here sorry, if I say here print a, it will print 15. So that is why a is a local variable, so it is local to this function. Whereas if I say c is equals to 20 and I ask it to print c, it will print 20 because this is a global variable. So this is how local and global variables are in Python. We follow the LEGB rule, which is local, enclosing, global, and built-in. So the first priority when we call that, for example, if we are referring to A, we first check local variables for A, and if there are no local variables, we check for enclosing, and then global, and then built-in. Built-in are predefined variables in Python. Global are something which are declared globally, which we just did, and enclosing is if we have a function inside a function, so that is the function which is outside will have enclosing. So that is how LEGB order is followed. That is the LEGB rule. Now let us discuss about function categories. There are different categories of functions. One is where there is no arguments, and also there is no return value, like how we had this add over here. Or let us declare another add where we have a is equal to 10 and b is equal to 20. So here we declared two variables and we are going to print a plus b. So this is a statement which will just print the addition of these two numbers, and these two numbers are inside this function. But anyways, um, this function has no arguments and no return value, because we have not assigned any return value here, and also we are not passing anything into this. So that is passing anything into the this when we are calling it as well, and also we are not giving any default arguments also. We look at what default arguments are later, but we can see that there is nothing passed into this, and also there is no return value. So that is why this category falls into no arguments and no return value. We can have functions like this. We can also have functions where we have no arguments, but we would have a return value. For example, let us say we are accessing pi. So we'll create a function called pi, and whenever pi is called, it will return the value 3.14. So this is something where now let me call pi. So it will return 3.14. So that is how we declare functions with no arguments but with a return value. And we can also have functions where we pass arguments but there is no return value. For example, here in add function, we have this return value. I can just say print a plus b instead of return, where it will just print the result and it will not return anything. We can have this as well. So this actually takes in arguments, but there is no return value. So this is a category of function where we have arguments but no return value. And then we have another category where we have arguments also and return value also, which we just saw right now for add function. And now let us look at argument passing, which is we have three types where we can have positional arguments, we can have passing arguments by keyword, and we can also have default arguments. Positional arguments is something which we use now, where we passed these arguments and that is how we accessed them. Let us look at this here, where I say I have a function which has a, b, and c. I'm passing a, b, and c into this, and I'm printing a first, I'm printing b next, and then I'm printing c. Let me call func with 10, 20, and 30 passed into it. So I got 10, 20, and 30. So if I change the order here, we see that 10, 30, and 20 is printed because that is how we pass it. So A is 10 and C is 20 and B is 30, because we are passing it in that way, and when we are calling it for printing, they're being executed in that way. We can also have keyword arguments where the order does not matter. So we can, instead of sending it here, I can assign it here. A is equal to 10, C is equals to 30, and B is equal to 20. Here the order won't matter, because when we print A, B, and C, it will be printed in the same manner. So even if I exchange B, it won't matter because it will still print it the same way. And we have the default arguments where we can assign default values to parameters, avoiding the need to provide them during every call. So for example, sometimes we can pass the arguments and even if they are not passed, we would have the default values to rescue us. So now let us define a function where I'll say fun2, and I'll pass a equal to 10, uh, b equal to 20, and c equal to 5, and I have print a, print b, and then I also have print c. In this, if I call fun2 and I pass 2 into it, I'll be getting 2, 20, and 5. This is because I'm passing 2 first, and the rest of them I'm not passing, but we have default values for them, so they will be executed and 20 and 5 will be printed. So this is how default values will be, this is how default arguments can be used. So now let us look at what programs we can do. We'll be doing 3 programs here, and then this one would be a homework, because you will have to learn about is upper, is lower, and is num, and all these functions which you may or may not have learned. So we will do these programs, and you can do this program after you learn those functions. So first one was menu driven program for a calculator. So let me say basic calculator, and I have so let's have functions where I have an add function where I pass a and b into it. It should return a plus b. So now the same thing should happen. We should have the same one for a subtraction as well, uh, and then we can have the same for multiplication where there is mul, and this function returns a multiplied by b, a divided by b. So this is how a plus b, a minus b, and a star b, and a divided by b can be executed. This can be a simple calculator, and we will ask for the choice from user of which operation would the user want to perform, which operation, 1 for add, 2 for subtraction, 3 for multiplication, and 4 for division. Let me restrict it to integer inputs. Now if choice is equal to 1, we will perform adding, and we'll ask them for inputs, a int input, enter a, and similarly we can have b as well. We'll pass in a and b into this. Let me print. So this is for addition. Same way we can do it for subtraction as well. Here we'll do it for multiplication for third option, and then we'll have division, else uh, print invalid input. Here, one thing which we could have done better was including A and B here itself after choice, so that we won't have to write it again and again. But since I was just copying it, it didn't make a lot of difference for me. So let us now use this. So I would want to perform add, where I will add 2 and 3. Okay, I forgot to change the name when I copied it there. So let me say print add 1, and it is giving me 3. So the same thing, if I use it for multiplication, it will give me 6, and if I use it for division, it can give me 1. Nice. So this is how it is working right now. You can also use a while loop here, where you can write while true and introduce a choice of 0, wherein if they enter 0, it can exit out of the program. Till that time, it will be repeating itself, and this will give it a proper calculator type program. I'm so sorry. Now let us do the second program, which is calculating the factorial of a number. We can use recursion for this. Recursion is when a function calls itself. So let us define a function called fact, which will calculate the factorial. If we pass n into the function, it will calculate the factorial of n. So if n is equal to 1, we have to have a separate condition, and else we can say return n star fact n minus 1. So we see that here we've written a separate condition for 1, which we'll look at later, but here we can see that we can do n is equal to n fact of n minus 1, because we know that n into factorial of n minus 1 is factorial of n. So when we call this function is called again, and n minus 1 is passed into this, until it goes till 1, it will be calling itself. So if we don't include this condition, it'll be infinite recursion. So we would not want that, so let's not do it. And if n is equal to 1, so 1 factorial is 1, so it should return 1. So this is fact. So let me pass fact of 5, it returns 120. If I pass 4, it returns 24. So this is how we can write factorial using recursion. It's very short and sweet. So now let us look at the third program, where we have to find the maximum element in the list. Let me write a function called find max, find underscore max, where I'll pass a list. Okay, let me say nums, where I'll pass a set of numbers, and when in the number, if the list of numbers is empty, I have to return none. So if I get empty, which is not nums, I will return none. Else, if it is not empty, we have to use a for loop for I in nums, where this will iterate in the list of numbers. So for each number, we will check if that is greater. So let us declare that nums of 0, let us assign this to max. I'll say max value. So this is the max value. The zeroth element in the list will be the max value. And if nums, if I, which is the number which is considered right now in the list during this for loop, if that is greater than max value, then that should be then that should become the max. So max value will be I. This is something which we'll do, and finally it should return the max value as output. So I'll let me declare nums as 1 2 3 4 and 5, and I'll pass these nums into the function of find max, and it is showing me 5 because that is the max value. So if I change it to 40, it'll give me 40. So this is how we can do the third program, which is finding the max value. So here in this code, we found out whether it is an empty list or not. Suppose I pass an empty list now. I just pass this. It should return me none. So that is why I included this first condition. And then so we can instead of passing it here, we can ask the user to give the input. So that is something which we can do, and there we have to ensure that it is not an empty list which is passed. So that is why we have to ensure this, and if it is an empty list, we have to return none. Else we have to follow the procedure where we have one variable which will have the max value. We have to first assign nums 0 to it, assuming that the zeroth entity, that is the first element in the list, is the max value. And if we find a contradictory if we find something contradictory to it, which is there is an element which is greater than max value, then max value should become that. So that is how we will do it. So this is how we have done the third program, and you can do the fourth program by yourself. You can also contact us at contact.rudrarvu gmail.com, or you can DM us on Instagram. And if you are part of the WhatsApp community and WhatsApp group, you can also message us there. So this was functions. I'll meet you in the next topic.